Welcome back to this discussion on ocean thermal energy conversion, wherein we have discussed about what is OTEC, what are the various cycles, something about the oceans, and the importance of having this source of energy, the difficulties, the limitations, etc. In the next module, we will discuss something about the byproducts of ocean thermal energy conversion, which could really add value and thus reduce the cost of ocean thermal energy conversion indirectly. What are the byproducts? One is indirectly we have seen is fresh water, then aquaculture, air conditioning, aquatherapy, control of global warming, production of other elements like hydrogen, methanol, ammonia, etc., production of uranium, gold, etc. So, this shows that how the byproducts from OTEC could be used for mariculture, for taking out various cultivating various organisms like oysters, lobsters, shrimps, etc., and how a building air conditioning can be used and things like that. As I indicated earlier, a 2 megawatt OTEC plant can produce about 43,000 cubic meters of fresh water. And this is really fresh water, it is DM water, that is demineralized water. Actually, to drink it, you have to add some minerals into that. So, this is available, and you can also see that it requires about 200 kilowatts of power supply, and many parts of India water requirement is more predominant. So water production is one of the important byproducts of OTEC. Now, deep ocean water mariculture. You know that the water which is taken from the deep sea is full of nutrients. They are actually not utilized at all. So, when the cold water is pumped from a depth of nearly a kilometers, and then after using for taking out the energy, etc., the water is let out at this depth, which is quite shallow. So the nutrients in this location are available at a shallower depth, and that will increase the primary productivity. You will have lot of various types of organisms, fish, etc. They all will come, and this will promote mariculture. To give an idea, I have shown what are the nutrients that are there, and what is the concentration in surface and what is the concentration in the bottom. So all these things are coming up, and thus we can have an improved mariculture along with this OTEC. And when you do this OTEC mariculture in Hawaii, they have done it in about 550 acres, as you can see here, and they have done it successfully for kelp, lobster, salmon, etc. As you can see in this picture, you can see all these mariculture cultivations in Hawaii. Another one is that the deep ocean water is cold, and after extracting the energy for OTEC and desalination, still it is cool enough. So, what you can do is that you can use in the copper nickel coils for deep ocean water circulation in a normal air conditioner, and of course normally the fan will be there. So this water, cold water that is circulating through these tubes, could be used for air conditioning. So you can see that this has been successfully demonstrated in islands like Bora Bora, and a 100 cubic meter per day desalination plant can additionally have 1000 tons of air conditioning, and in NIOT also has done this in the islands of Lakshadweep. Now coming to production of hydrogen, you see that conversion of natural gas using steam is the common methods, but you can do electrolysis of water and you can get hydrogen. As you can see here, it's a very simple method, and hydrogen can be compressed and stored, and it can be converted to ammonia and transported, and you can see that a 100 megawatt plant will yield about 1300 kilogram per hour of liquid hydrogen. So this is another byproduct, and you know that when hydrogen comes up, you can use it for various applications. Next is ammonia. Ammonia is a backbone for fertilizer and chemical industry, as we all know. So it is again normally produced from natural gas or coal, and you see that 1.8 tons carbon dioxide emission per ton of ammonia is there when you do in that way, whereas through this mega OTEC plant we can produce about 300 tons per day, and that is another byproduct. Uranium, using an absorption method using polymeric absorptions, can recover uranium from seawater, and this has been reported by Japanese researchers, and you see that this is how the plant works as a which produces uranium in addition to OTEC. And there is also a slightly different variance wherein a new braid absorbent was tested, and it does not need any heavy absorbent cage for absorbent stacks, and you can see that this is how it is being done. The braided absorbents are put here, and you can generate again uranium using this method. Lithium, which is actually about 14 million tons in land and 230 billion tons available in seawater, and you can use using absorbents. This also could be produced, and that is again a byproduct. Now coming to the environment aspects, what are the positives? One is it is not at all toxic and no toxic products are released. Carbon dioxide is again less than 1% of fossil fuel plant. Nutrient rich cold water is there, cold water for air conditioning, and fish will be attracted. Mariculture comes, but there are some negative points. As I told earlier, everything there will be some negatives. One is there are many organisms which get impinged because you are pumping cold water and warm water. The organisms in that region gets impinged and gets into it. That is a concern for environmentalists. And similarly, there is a mixing of warm and cold seawater that is taking place. Even though mariculture growth is there, the temperature difference in that particular region affects that portion. So dispersion studies are to be done extensively. And another important aspect is that OTEC is in the R&D stages, and there are only a very few plants working, and what are the issues which can come over long periods is really not studied. In this section, we have gone through the various byproducts which are available from the OTEC and which can reduce the overall cost of OTEC plants. In the next section, we will go through the OTEC plants in India and how work has been going on in India, very specifically with respect to OTEC. Thank you.